Okay, to solve part B of this problem, I want to find the rate constant. And so we already determined the rate law in part A, so all I need to do is pick any one of the 4 trials, plug in the concentration for each of the reactants, plug in the rate, and solve for K, and that will give me the value of the rate constant. Now, I typically like to solve for the variable that I'm looking for before I plug in the values. Right? So in order to solve for K, I need to divide both sides by a squared times b. So when I do that, I'm going to end up with K is equal to the rate divided by a squared times b. And I can pick any one of the trials that I want. I'm just going to go ahead and pick trial 1. And so when I plug in my values, I have the rate, I have my 2 concentrations, and when I divide that out, the numerical answer is 5.00 times 10 to the third. Now, anytime you give a result, we need to also include the units. So we need to see how those are going to come out. So if I look at the molarities, I have a molarity in the denominator, and I have a molarity in the numerator, so those are going to cancel out. Now what I'm left with is 1 over seconds over molarity squared. Now remember, I can move a quantity from the denominator into the numerator. I just have to change the sign on the exponent. And so 1 over seconds, that's the same thing as seconds to the minus 1. And I've got 1 over molarity squared, so that's the same thing as molarity to the minus 2. So I could write this in 2 different ways. I could write the units as 1 over molarity squared times seconds, or I could write it as molarity to the minus 2 seconds to the minus 1. I prefer that second way. You could report it any way you want, but you need to be comfortable converting back and forth between those 2 different styles of writing the units. Oops. So that is the answer to part B. That is the rate constant and the units.